In this video we walk you through the basic concept of mapping your drive to your machine with the following question in mind: how does your machine determine your power drive system? We will zoom in on how the motor drive combination should match the load versus torque characteristic of your machine, and we will briefly touch on transient and torque pulsations and finalize by strongly appealing to collaboration between the stakeholders right from the beginning of the project. For now, let's take a look at the old-fashioned torque versus speed characteristics of a asynchronous direct online motor. Typically, the synchronous speed is 60 times the frequency divided by the number of pole pairs. In a 4-pole motor on 50 Hz, this leads to 1500 RPM or 1500 revolutions per minute. Let's connect this asynchronous motor to a machine, and as an example we take the Archimedean screw. When it is turned, it will lift the water, and this results in a load torque that increases linearly with the speed. We find the actual operating point at the intersection of the two curves. This stable operating point is characterized by the balance between load and motor torque, resulting in a constant speed. And in the case of an asynchronous motor, this speed is some percentages lower than the synchronous speed due to the motor's inherent slip. In the following diagram, we will show the effect of a variable frequency drive driving the motor. It becomes clear that changing the frequency will result in another synchronous speed and therefore also in another speed of the driven machine. The sinusoidal waveform produced by the variable frequency drive, which has an adjustable amplitude and frequency, allows for variation in the speed of the machine as shown in the diagram. We notice that the field of operation unfolds for this machine. For successful operation, the field of continuous operation should remain below the green indicated curve. Machines that impose a load evolving with the square of the speed are quite common in various industries. Examples include centrifugal pumps, forced draft fans, induced draft fans, sinterfans, boiler feed pumps and centrifuges. The square and linear loads are often referred to as variable torque applications. Variable speed for these machines offers significant potential for energy savings with short payback periods. These applications fall under the category known as general purpose or standard applications. Examples for constant torque include conveyors, augers, reciprocating compressors, crushers, positive displacement pumps and kilns. Continuous operation above the declining green line and up to the dotted green line is only possible in case of forced cooling, for example totally enclosed fan cooled or IC4116. Above the base speed, we now go into the zone called constant power. Above the base speed, that is this part here, the continuous available torque decreases, of course, its constant power inversely with the speed. Notice also that there is a substantial decrease in available transient available torque in the oversynchronous zone. Examples include center winders and grinders. Now, what are the key takeaways for this video? Well, first of all, ask your machine manufacturer to provide the machine's specific torque versus speed curve for continuous operation. The motor drive combination should deliver a torque versus speed that covers the required machine torque over the entire speed range. Candidates for variable speed drive motors combinations or solution providers should include this map diagram in their quotations. Okay, this relates still to the steady state operation, but in many applications the drive combination must also deliver short transient torques often surpassing the rated motor torque. For example, consider a large loaded conveyor belt in the cement industry where up to 180% of rated torque can be required just to start it up. This is often called the breakaway torque. Another example is a rubber mixer with regular substantial torque surges because of the operation in batch mode. New batches can impose up to 250% of rated torque. It is clear proper sizing of the motor and the drive needs to be considered. Further investigation of the machine's expected dynamic behavior related to torsional analysis and resonance speeds may be required in some cases. And last but not least, the close collaboration of your project team with your machine manufacturer is preeminent. We advise you to reach out to us for independent expert assistance on proethic.com for your project team in organizing pre-bid meetings, setting up invitations to bid and getting vendor neutral advice on your power drive system. Don't forget to like, subscribe to our channel and for more interesting tips about medium voltage drives.